over. We're talking about what today? Matrices, yes. So before we talk about matrices, we need to learn how to solve systems of linear equations by substitution and elimination. What are the two methods?
Substitution and elimination.
Good. Substitution and elimination. When you hear the word substitution, what do you think of? Changing something for something else. Very good. What do you think of when you hear elimination? Getting rid of something. You got it. So this is what we're going to talk about today. We're going to talk about solving systems by doing exactly that. So our goal is we want to solve, or we want to learn about systems of linear equations, how to solve systems of linear equations by substitution, and how to solve systems of linear equations by elimination. And then we're going to do some applications of systems of linear equations because we want to see how to apply this stuff that we learn into the real world. Yes?
Yes.
All right. So let's start out with a definition. Good morning. I said good morning.
Good morning.
All right. So let's start out with the definition. A system of linear equations with no solutions is called inconsistent. This is called inconsistent. So a system of linear equations. So for the sake of these graphs that you're going to see, I'm talking about a system of two linear equations. How many linear equations? Two, which is why you'll see here two lines. Okay? So a system of linear equations with no solution is called what? Inconsistent. Let's say this one more time. A system of linear equations with no solution is called inconsistent. Okay? Graphically, what does this mean? Graphically means whenever you graph those two lines, they have no points in common. There are no points in common. That's why I have this written out here. No points in common to both equations for a system of two linear equations. When you hear linear, what do you think? Lines. Yes? Okay. So if you have a system of two linear equations and there is no solution, that system is inconsistent. You better believe it. So go figure. If you have a system of linear equations that has at least one solution, what do you think it's going to be called? Consistent. You got it. This is called consistent. And so if you have a consistent system, you then have two new terms that you have to learn because you may have infinitely many solutions or you may have exactly one solution. Okay? If you have a consistent system that has exactly one solution, that is called independent. That will be called independent. And graphically, it looks like those two lines of your system of two linear equations intersects in one point. Right? That means they have that one point in common. So 1 point common to both equations in that system of two linear equations. Okay? A consistent system with an infinite number of solutions is called what? If it was independent for exactly one solution, it's dependent for infinitely many. Very good. Your intuition is great. Make sure you remember this. Okay? A consistent system with an infinite number of solutions is called dependent. So in other words, these two equations, there should be an S here. It was cut off when I scanned this in. So make sure you add the S. The two equations that coincide. So in other words, the two equations represent the same line. So they stacked, like you just said, they're stacked. They lie right on each other. And it's good to put it in your words. They're stacked. So that means every point is a solution because it overlaps. Does that make sense? Okay, so let's do a quick review. If you have a system of two linear equations and there's no solution, your system is inconsistent. Great. If you have at least one solution, your system is consistent. Yes. If your consistent system has infinitely many solutions, it is called dependent. Yes. If there is exactly one solution for your consistent system, it is called independent. Excellent. Excellent. So now we need to see how to solve these systems by the two methods that we discussed. What were the two methods we talked about? Substitution and elimination. You got it. So first, we're going to talk about solving by substitution. So as Bethany said, that was changing one thing for another. Okay? So when we talk about a linear equation, we have what variables? Two, yes? What are they? X and Y. Good. So we have two variables. So whenever we have that, we're going to have to choose, if we're solving by substitution, we're going to have to choose one equation, solve it for a variable, then substitute that into the other equation. That's solving by substitution. Okay? So, how to solve a system by substitution. Example 1. Solve the following systems of equations by substitution. If a system is dependent, what does that mean? They stack. The lines are stacked in terms of solutions. What does that mean? Infinitely many, yes. So if the system is dependent, express the solution set in terms of one of the variables. That helps us indicate that there are infinitely many. And so we'll explain that when we get to it, if that occurs for one of our examples. Okay? So, your book, whenever your book talks about a system, they'll put this curly bracket on the outside. I tend to leave it off. Okay? I tend to leave it off. That's just me. I'm okay if you use that. Okay? But you won't see me use that often.
Oh, both ends are just
Just the front. They only do it for the front whenever you're talking about a system, because whenever you have the curly brackets on both and you put elements on the inside, that means you have a set. So if you have 1, 2, etc., this is a set. But if you choose to use this, do you want me to use this for this first example? Yeah? I'll use it for the first example, but after that, I won't use it. But if you want to use it, you can. Yes? Okay. So, we have two equations. 2x minus 4y, two linear equations. 2x minus 4y equals -6. And then 3x minus y equals -4. We want to solve this system. Okay? We want to solve this system by substitution. Okay? We have to solve the system by substitution. Now, when you're solving a system by substitution, you can choose either of the equations. You can choose the equation 1. I'll call equation 1 the equation that's on top. Guess what I'm going to call the one underneath? Equation 2. Yes? I'm going to call this equation 1, this equation 2. Now, it doesn't matter. It does not matter whether you choose to solve equation 1 for a variable or equation 2. What matters is the process. Whichever one you choose to solve for the variable, you then substitute that equation, that one that you solve for, into the other one that you did not solve for. Okay? Now, I look at this equation 1. I see a coefficient in front of each of x, in front of x and in front of y. And then I have a constant term on the right. I'm going to choose to use equation 2 because there's only this one here, -1. So I'm going to solve. So the solution here. We're going to solve for any variable. I'm going to choose equation 2. Okay? So we have 3x minus y equals negative 4. So I'm going to choose to solve for, guess what? Y, right?
Right.
Okay, so we're going to add 4 to both sides, and then we're going to add y to both sides. So this becomes 3x plus 4 minus y equals 0. Then we're going to add y to both sides to get 3x plus 4 equals what? Y, right? So we've solved equation 2 for y. I'm going to call that smiley face. Now, because we're solving for substitution, we're now going to substitute 3x plus 4 in for y in what equation? The top one, right, equation 1. So now, using smiley face and equation 1, substituting gives the following. Can you still see this? Can you still see this? Yes? No? Okay. So So substituting now gives the following. We're now using the equation 1, yes, and we're using the fact that y is equal to 3x plus 4. So now we know 2, still use red. We have 2x minus 4 times what?
3x plus 4.
Yes, 3x plus 4. That's equal to?
Equals -6.
You got it. And so now notice that equation 1 is going to be in terms of how many variables? 1, which is x. So now we'll be able to solve for x. And once we have x, we can then plug that or substitute that back here into y to find out what y is. Okay? That's because I moved it. It'll adjust. There you go. So let's do it. So we have 2x. What do we have? What do we have? Equals -6. Good. Say it loud. Because this is really a -4. If you choose to do it that way that you mentioned, it's not incorrect. Let me tell you what you would have. So this is an aside to explain what Akeem asked. If you choose to do it that way, it becomes 2x, and then you have to put a bracket or a parentheses. And then you would have 12x plus 16 equals -6. But that's what you would have. But then what you'd have to do is distribute the negative. This way is fine as well. And instead of brackets, you can use parentheses. So if you chose to do it that way, that's perfectly fine. You'll still end up here. Can I answer your question? What other questions do you have? Okay? All right. So now we combine like terms. You have 2x minus 12x. What's that? -10x. Great. And then we're going to do what with the -16? Add it to the other side, which will result in
10.
Or not equals. Good. -10x equals 10. Now we do what to both sides? Divide by what? Good. So x equals? Thank you. X equals what? -1. Very good. X equals -1. So now we know x is equal to -1, so we go back to what? I labeled it. 3x plus 4. We know y is 3x plus 4, so we go back to smiley face. Y is equal to 3x plus 4, so we know x equals -1, so y is equal to 3 times what? -1 plus, which is equal to? -3 plus 4, which is, as you said, 1. So our solution here is -1, 1. You got it. That's your solution. That's the solution to your system. And notice it's the point -1, 1. Right? It's the point. Because you have a system, that means that these two lines intersect in one point. It is what? Go ahead. So this system is independent, and what's the other word? What is it? Not constant. Consistent. Good. The system is consistent and independent. You got it. Very good. What questions do you have? This is solving by substitution. What questions do you have?
Where did the positive 1 come from?
Yes, as she said, -3 plus 4. So we took -1. Let me use a green. We took -1. We substituted that over here in smiley face for x. And then we simplified. What other questions do you have? Okay, let's keep it moving. All right, another example. We have the following system. 3x plus 6y equals -12, and 2x plus 4y equals -8. What's your approach? Solve for any variable. What equation do you want to use? It doesn't matter to me. Second one? That's fine. If you choose the first one, that's fine too. Either one. Choose whatever one makes you happy and then follow it. Okay? You said choose equation 2, so that's what we'll do. So, equation 2, what variable do you want to solve for? X, okay. So when I said x, we'll go with that. So we have 2x plus 4y equals -8. You said you want to solve it for x. So if we're solving for x, that means we want to get x by itself. So we then have to do what to both sides? Subtract what? By what? 4. Just 4? 4y. You got it. 4y. Subtract 4y from both sides. So that gives us 2x equals -4y minus 8. We want x by itself. So now what do we have to do to both sides? Yes, very good, both of you. So we're going to divide both sides by 2. So then we have 2x over 2 equals -4y minus 8 over 2, which means x is equal to, what's -4y divided by 2? Good. And then what is minus 8 over 2? Good. So we have negative 2y minus 4 is equal to x. So we solved equation 2 for x. Now what is our approach? What do we do?
Substitute.
You guys substitute that into the equation 1, yes. You want to call it smiley face again? Now, substitute into equation 1. To get the following. 3 times what? Good. Plus 6y, good, equals negative 12. Notice that we now have an equation in the variable what? Y. Very good. Yes? So now, tell me what we get. Either one. Y'all can keep going. Equals negative 12. What happens on the left? They do, leaving us with negative 12 equals negative 12. Add 12 to both sides. What does that give us? What does that give us? 0 equals? That's always true. Negative 12 equals negative 12. You can make the same conclusion at that step. You can make the same conclusion at the step where you have negative 12 equals negative 12. This is always true. Always true. Which means, what type of system do we have? I heard inconsistent. I heard constant. Do we have constant systems? What's that word? Consistent. So we have to determine if, let's think about this for a second. We ended up with the substitution. We're not complete. We ended up, after we substituted, we ended up getting a statement that is always true. Is that false? No, because it's always true. So, does this mean we have no solution? It means we have how many? Infinitely many, because the statement is always true. You got it. So, is our system inconsistent or consistent? Consistent, okay? So, we ended up with a statement that is always true. So that means we have a consistent system. And whenever you have a consistent system, you have to determine if your system is independent or dependent. Which one? You said independent or dependent? Dependent. Consistent and dependent, which means there are infinitely many solutions. Does that make sense? Yes? So, our instructions tell us if a system is dependent, we have to express the solution set in terms of one of the variables. So, we are going to highlight the fact that x is equal to negative 2y minus 4. What's x equal to? So if we are writing a set, we have to write our solution set. We have to describe our solution set in terms of one variable. What's x? That goes in your x coordinate. And y is just y. This vertical bar means such that. Now we're reminding ourselves set notation. Y is an element of the real numbers. So let's remind ourselves of our set notation because it's been a while since we've seen it. You want me to write it out in words? No? Okay, I won't. Curly brackets on both sides indicates the set of all ordered pairs, negative 2y minus 4, comma, y. That's your x. This vertical bar means such that y is a real number. You got it. This means belongs to or is an element of. Belongs to or is an element of. This means belongs to or is what? You got it, an element of. So let's read it. This is the set of all ordered pairs, negative 2y minus 4, comma, y, such that, you got it, such that y belongs to the real numbers. That's absolutely correct. So this is your answer. Now, if you chose to solve your equation for y, bless you. If you chose to solve your equation for y, you would then write x, comma, whatever that equation was. That would still be an answer for this problem. Does that make sense? So that's what I'm saying. You have to follow your way. There are a couple of ways you can approach this, but they'll all get you to the same point. You'll always end up that you have a true statement here, which means what about those lines graphically? They're stacking, so they're the same, yeah? That means those lines are the same. Okay? So graphically, what did I do? Say it again. Yes. Well, you'll be missing something. If you do not have this vertical bar, you'll be missing something. So yes, you want to put such that. Some people put colon, like some people put colons here, like the 2 dots, vertical dots. Some people put those. I use the bar. But yes, so you need that. Okay, what other questions do you have? All right, we talked about solving by substitution. What's our next method? Eliminate.
Negative 2y minus 4. How you get the 4 is negative 4y minus 8 over 2.
Because we divided both by 2. Negative 4y over 2 is 2. Negative 2y. Negative 8 over 2 is negative 4.
Okay, so also
I need you to talk loud.
So 2x.
So what we did was
The 2 cancel out.
the 2's cancel, yes.
Okay.
And then here, that leaves you with a negative 2, and that leaves you with a negative 4. Yes. What other questions do you all have? So what I need you all to do is to make sure you ask me the questions, right? Because I can clear it up for you quick, and you can understand it, and we can move forward. That's the benefit of being in class and being able to engage in this way. What other questions do you have here? Oh, wait a minute. Elimination is my favorite. But you choose what works for you. Okay? Now. Question?
You can use either or.
Mm-hmm. If it just says solve the system without saying the method, then you can choose. But if it says solve by substitution, you have to use substitution. If it says solve by elimination, you solve by elimination. But if it just says solve the system, it's fair game for you to choose. What other questions do you have? What's your question? Toy. Talk loud. Okay. All right. So now we want to solve systems by elimination by using the method of what? Elimination. Yes. Okay. So We want to solve the following systems of equations by elimination. If a system is dependent, meaning you have how many solutions? Infinitely many. Express the solution set in terms of one of the variables. So, okay, here in our first system, we have 5x minus 10y equals 9. Our second equation, we have negative x plus 2y equals negative 3. Now, when you solve by elimination, you told me elimination means what? You're getting rid of something, right? So if we're solving by elimination, that means we want to get rid of one of the variables. If we're getting rid of one of the variables, that means that one expression has to be the opposite of the other expression. You with me? So if we want to eliminate the x here, you have a 5x, so ideally you want this to be a negative 5x, right? So very good. So that's what we want to do. So in order to make this a negative 5x, we're going to have to multiply equation 2 by 5. Okay? So your book, again, would have a curly bracket on that side to indicate you have a system. So I'll do it for this problem, although I won't do it for any more. I said that before, but I'm doing it for this one. Just because I think it'll be easier for you to see it. I think it'll make it a pop better. So here we have 5x. Equation 1 is not changing, right? But now we're going to multiply both sides of equation 2 by 5. And what we do to one side, we're doing to the other side as well. So we're not changing our system. Okay? Now, our system then becomes, what's equation 1? So tell me. So,
5x minus 10y
equals 9. Good. What does our second equation become? Negative what?
5x
Oh, negative 5x, yeah?
plus 10y
Mm-hmm.
is equivalent to negative 15.
Yes. And so now what we're going to do is put a bar underneath because we're about to add vertically. That's why everything is aligned. Are you with me? Are we on the same page? If so, I'm going to need to hear more than that. If not, I'm going to need to hear questions. Are we on the same page?
Yes.
All right. So we're adding vertically. 5x minus 5x is x or what? 0. Negative 10y plus 10y is? So we have 0 plus 0 equals. What's negative 6? So that means 0 equals negative 6. Is that true? No, this is a false statement. So we have a system that ended up to be, it resulted in a false statement. Which means what about our system? It has no solution. So, very good. So our solution, we write as the empty set. Remember, this means empty set. Solution is the empty set. And what do we say our system is? Inconsistent. You got it. What questions do you have?
So, you know how we took the 5x and eliminated it and put it in the second equation? Or,
Say what now?
you know how
Are you in, so 1, 2, or 3? 2. Okay, go ahead.
So we took the 5x and put it in the second equation. I mean the 5.
We multiplied equation 2 by 5.
Right, you know how we took it. We did it from x, can we do the same for y?
We multiplied all of equation 2 by 5. So yes, we did multiply 2y by 5 as well. Is that your question?
I was asking, like, if we were to take the 2, could we do the same with the 2y?
Say what now? Ask me again.
I was wondering if we could do the same with the y.
Where?
As we did with x. Like,
Oh, can you choose to cancel out the y? Is that what you're saying?
yes.
Yeah. You can choose to cancel out the y's instead of canceling out the x's. And it just happened that we did both at the same time. So if it's set up to where you want to cancel out your y's, you can choose to cancel out your y's instead. Yes. Yes. We just chose to cancel out our x's and we ended up canceling out the y's as well. But if you chose the path where you wanted to cancel out your y's, yes, that's absolutely fine. That's absolutely fine. You want to cancel out the y's in the next one?
Yes.
Okay, we'll cancel out the y's in the next one. So you can see how it will work. What other questions do you have here? Okay. So Marcus wants to see the y's canceled out. So we have our system. 5x minus 6y equals -1 is what equation? Equation 1, yes. And what is equation 2? Good, -4x plus 3y equals -10. That's our system. And this is why I guess it's useful for you to write that curly bracket on the left of your system whenever you're rewriting the system each time, so it'll stand out for you. So I could see that as a benefit for you if you choose that way. I'm okay with that. So if we're gonna approach solving this system with Marcus's approach that we want to cancel out the y's. If we want to cancel out the y's here, what do we have to do? Multiply what?
6.
Multiply 6?
-6.
Multiply by -6? Multiply what by -6?
-4x.
I can't hear you, and I know you talk loud outside of here.
-4x and 3y. And then 10, -10.
But let me ask you this. If we multiply all of this by, what did you say?
-6.
If we multiply all of this by -6, what is this going to become? What is that going to become? -18y. Will that be able to cancel this out? No. So that's a good error. And let me tell you why. Because it then tells you what you need to think of. So that's a good suggestion, which said that you know you need to multiply this second equation by something. So that's very good to identify. That's the observation. That's an excellent observation. So now the question is, instead of -6, what do we need to multiply equation 2 by in order to cancel the y's? 2, very good, because if we multiply equation 2 by 2, that's going to turn this into what? 6y, and then you're going to have a -6y plus a +6y, which will cancel those out. Does that make sense? Honestly, whenever you master that concept, that's going to make the rest of this entire chapter much less challenging for you. Okay? So, want the curly bracket on the left? Okay. So we're rewriting our system. So equation 1 is equation 1. And you told me we need to multiply equation 2 by 2. So we're going to write 2 times -4x plus 2 times 3y equals 2 times -10. So now what does our system become? The top stays the same. Yes.
Negative 8x
Yes.
plus
Talk loud.
6y
Yes.
equals negative 2.
Nick equals what?
Negative 2.
-2? -2 or 20?
10. Oh, yeah.
Ah, because it's -10. Yes. So -20. Very good. So just be careful with the numbers when you bring them down. And at this point, what do we do now? Add vertically. You got it. So we're going to put that bar underneath the equation 2 because we're going to add vertically. Now what do we get?
3x.
-3x.
0.
What do we put in between? Plus 0 equals -21. That means -3x equals -21. So good. Yeah? Now what do we do to both sides? Yes. To get x equals? -7 or 7? I heard both. 7 because we have a negative over a negative makes it a yes. So we get x equals 7. Are we done?
No, you gotta plug it in.
We got to plug it in to find?
Y.
To find y. Does it matter whether you use equation 1 or 2? No. Which one do you want to use? I didn't hear you. 1? Okay. So x equals 7. Now find y. So using equation 1, we have 5 times what? Yes, minus 6 times y equals -1. 5 times 7 is?
35.
Good. 35 minus 6y equals -1. Do what to both sides? Subtract 35. Good. So that leaves us with 6y equals? -6y equals? -36. Divide both sides by? Good. To get? Yes. Y equals 6. So tell me how we write our solution. Parentheses. 7,6 parentheses. You better believe it. Excellent. Excellent. So you've learned how to solve by substitution and elimination. We solved a system of how many equations? 2. What kind of equations? Linear, yes. We've learned what kind of systems? Consistent and inconsistent. Consistent means what? Say what? At least one solution. If we have exactly one solution, our system is consistent and independent. Good. If we have infinitely many solutions, our system is consistent and dependent. Good. So whenever you have a dependent system, graphically, that means lines are the same. If you have an independent system, that means the lines do what? Cross and intersect at one point. Yes? If you have a system that doesn't have any solutions, it's called inconsistent, which means the lines are parallel. That's fine. Yes. Okay? There you go. Okay? So that's what we have. So now let's do some applications. Okay? Let's talk about Karen. Applications. Marcus is having a moment.
Oh, my contact lens had broke. So,
Oh, my bad. I'm sorry.
yes.
I apologize. Karen. Karen empties out her purse and finds 45 loose coins consisting of entirely nickels and pennies. Yeah. If the total value of the coins is $1.37, how many nickels and pennies does she have? Let me say it again because y'all love it so much. And y'all yawning and sneezing and stuff when I say that. I don't know how to feel.
Word problems is.
Word problems is exciting? No, but let's talk about this. We got a pocketbook. We got some money. Yes? And we got to figure out how much of each we got in our bag. Right? It's for real. It happens. Okay. So, let's break it down. We got, what type of money do we have? Nickels and pennies. So let's set it up. We're gonna let N be equal to the number. Can I use hashtag for number? Number of nickels. We're gonna let P be what? Number of pennies. Got it? Okay. So now let's talk about what we know. Let's just identify information. What do we know?
45.
So yes, we know the total number of coins. Total number of coins is what?
It's equivalent to 137.
Wait a minute.
Oh.
The total number of coins?
Oh.
That means how many coins we got? 45, yeah?
Oh.
Total number of coins is 45. But if you want to talk about the total value of the coins, that's what? Is what?
$1.37.
Okay, I thought I heard 36. That's what I was like, wait, what? So the total value of the coins is $1.37. I'm with that. What else do we know? Say what? Nickels and penny. What's a nickel? 5 cents. We smart. We got this. The value of a nickel. Value of a nickel is equal to 5 cents. 0.05. What else do we know? Value of a penny is what? 0.01. Good. We know anything else? No, that's what we know. I see you shaking your heads. That's what we know. Now we need to figure out what N is and what P is. So let's set up our system. What's an equation? Can you tell me an equation that we have in our system? Say what? I can't hear you. 5 times N? You mean 5 times N? Where's the 5 coming from? Value of a nickel. What's the value of a nickel? Is it 5? 0.05. So I'll give you that. So 0.05, continue. Oh, what am I writing? 0.05 N, continue. Good. Equals $1.37. You better believe it. That's one equation. Excellent. Excellent. What's the other one? N plus P equals what? 45. You better believe it. So something that looked very complicated, you broke it down. You identified what you knew. You broke it down and interpreted 2 linear equations from that, and you set up your system. Yes?
Yes.
So now we got to solve it. Which method you want to use? Elimination. So what do you want to multiply everything, or what do you want to do? The first one? I can't hear you. Huh? The pennies? Okay. So you chose elimination. So I'm going to put this curly bracket. If you choose substitution, you can do substitution. If you choose it, you're going to get the same exact thing. Do it your way. Whatever way you want to approach it. Okay? I'm going with Gerald because he said elimination. Okay? So, here, you say you wanted to eliminate the pennies? Okay, so if you want to eliminate the pennies, is equation 1 changing? No. So 0.05 N plus 0.01 P equals 137. Okay, what are we multiplying equation 2 by? Negative 0.01, you said? Okay, so negative 0.01 times N plus negative 0.01 times P equals negative 0.01 times 45. We good?
Just 0.01.
Because Gerald said, go ahead, Renati.
Oh, because we're trying to cancel out the P's.
Right on.
All right, he said right on, I got you. Okay. So we good? Are we good?
Yeah.
Okay, so I need you to tell me what we're going to have. What's equation 1? What's equation 1? What's equation 1? Good. What's equation 2 now? Negative 0.1, you said? Negative 0.1? Oh, negative 0.01. Negative 0.45. And now what are we going to do? Add. So we're going to put that bar there. We're going to add vertically. Yes? 0.05 N minus 0.01 N is? 0.04 N. What happens next? They cancel out. Yes? So plus 0 equals 1.37 minus 0.45. Say what? 0.92. Okay, good. So we now have 0.04 N equals 0.92. What do we do to both sides? Yep. And we get N is equal to? So that means she got what? 23 nickels, but the question says how many nickels and pennies does she have? Say what? 45? But it says how many nickels does she have? How many pennies does she have? Subtract 23 from 45? Yeah, go ahead. Ask your question.
How do we get 23 nickels?
Good. 0.92 divided by 0.04. You're welcome. 0.92 divided by 0.04.
I thought that would have been like the point numbers.
No, because technically when you divide 0.92 by 0.04, you have to move this over when you divide it out. So you get N is equal to, and you can check it. Go ahead and check it. Confirm if you would like. I would like you to actually confirm that 0.92 divided by 0.04 is 23. Yes? Okay, we had to confirm. So we get N is 23. So you have 23 nickels. And then you said to find the pennies, you do what? Subtract 23 from 45, yes? So the number of pennies is going to be 45 minus 20. 45 minus 23, which is what? 22. So to answer the question, she has 22 pennies and 23 nickels.
And if it wasn't pennies, we would have to plug in that 23, right?
Say what?
If we weren't using pennies, we would have to plug in that 23, right?
What do you mean? If you weren't using?
After we had got the N is equal to 23,
Mhm.
we have to plug it into
You're plugging that in, so you're plugging that in here. So you have N is 23 plus P equals 45. So you have N plus P. This is an aside to answer your question. You have N plus P equals 45. So then you have 23 plus P equals 45, or P is equal to 45 minus 23. What other questions do you have? What other questions do you have? This is a real world application. Yeah? Actually, 5. Another page. What does it say at the top? You want it? I haven't even started grading yet. So, this is my problem. This is an application. Yes? So, Jack and Tyler went shopping for summer clothes. Y'all still go school shopping? Yes? No? I heard both. Jack and Tyler went shopping for summer clothes. Shirts were $12.47 each, including tax. And shorts were $17.23 per pair, including tax. Jack and Tyler spent a total of $156.21 on 11 items. How many shirts? And pairs of shorts did they buy? Okay. Jack and Tyler went shopping for summer clothes. Shirts were $12.47 each, including tax, and shorts were $17.23 per pair, including tax. Jack and Tyler spent a total of $156.21 on 11 items. How many shirts and pairs of shorts did they buy? Got it? It's 10:42. I'll give you 5 minutes. I think that's enough time because we went through the previous example and I know you can do this. So it's 10:42. I'll give you until 10:47, and then we take the last 3 minutes for you to present it to me. Deal? Deal? Can you work in groups? Yes. What does that require? You to talk, yes, and move around and do that. Okay, have fun. Okay, that's okay. You can always correct.
Our second
Yes?
equation, when we put the number.
Okay, so we're recording now.
Not
Yeah.
the number with the variable.
Thank you for giving me the extra time at the end because so you can get your 5 points. Yes.
So it's negative.
Okay, everybody paying attention?
3, and then just add.
Everybody paying attention? That's the question.
So just
Everybody paying attention?
We
Oh,
put the
you didn't turn the light
17
off?
as 17p, 1711. So we only multiply 11.
Okay, Shay, when you explain it, I need you to talk loud.
Okay. The 2 equations I wrote down was 12. Oh shit. 1247 S plus 1723 P
Make your
equals,
points a little bit
Oh.
darker, bolder.
there it is, equals 156.21. And my second equation was S plus P equals 11.
Can you tell me what S and P are on the side somewhere?
S is for shirts and P was for the shorts.
Okay, put S is for shirts, P for shorts on the side
Oh,
somewhere.
okay.
It can be beside the word problem if you want. You always have to label your variables because we need to know what they mean. Because we're communicating, yeah? Okay, keep going.
Okay, and then I solved this by elimination. So you have 1247 S plus 723
Good notation. Notice she put the curly
P
bracket out front to
equals
indicate she's dealing with another
156.21. And then I wanted to eliminate P, so I do negative 17.23 S plus, oh wait, no, minus.
You good. Keep going.
Minus 1723 P, oh,
Just a minute. Keep going.
23P equals
Talk loud.
negative 1723 times 11.
Are we good so far? That's a question.
Okay.
Okay, keep going. Talk loud where they can hear you in the back.
Okay, so you do 1247 S plus 17.23
Make sure
P
your points are bold.
equals 156.21. And you have negative 17.23 S minus 17.23 P equals negative 189.53. And then your middle terms cancel out, so then you're left with negative 4.76 S plus 0 equals negative 33.32. Can I zoom like
Yes.
move it? Okay.
Mm-hmm. There you go, good.
Okay.
We'll be done in a minute.
And then now you have negative 4.76 S equals negative
Continue to talk loud.
33.32, and then you divide by your negative 4.76 on both sides, and then you get
Negative, right? You said negative, but yep,
then you get S equals 7, and then when you plug that into the second equation, you get
Oh,
P equals 11 minus 7, which is equal to 4. Now you have 7 shirts. Wrong one. Now you have 7 shirts and 4 pairs of shorts.
and we boxed it, yeah? And what else can we do? Because she did a good job. Excellent, excellent. What questions do you have? What questions do you have? Make sure you come sign the iPad with your first and last name before you leave. Make sure you print it so you can get your 5 points added to your exam. Yeah? Have a great rest of your day.